Welcome back. Hi, Andrew.
G'day, Bex. How you doing?
I'm really good. It's so nice to be doing this again with you.
Oh, it's fantastic to be here.
I know I said that yesterday, and I'm saying it today because I'm really, really happy to see
great
you
every day.
again. So you're going to be talking about a cardboard box. No, you're not.
We are. Well, a little bit more than a cardboard box, but yes. Some magic that goes in the cardboard box.
The magic that goes inside one of these cardboard boxes. So the guys over there have been working on VR projects, and you've kindly come to share with us today the virtual Google store.
Yes.
And we've actually got a Google store, the first one in London.
Yes.
That Liz went to visit.
Oh, Liz has been there.
Yeah,
Great.
Liz has been. She did her research
Very
before
good.
going. So Andrew's going to talk to you about how they use Nuke over there on that. And if anybody in the theatre, sorry guys at home, anybody in the theatre who's curious to see the virtual store, we've got viewing retro styly tings round there, so you can go and have a look afterwards. So I'm going to hand it over to you. Again, questions, hashtag TFNAB, and we will ask Andrew for you. Over to you, babes.
Thanks. All right, good afternoon, folks. Now, my name is Andrew Ashton, and I'm the compositing supervisor at Mirada Studios in Los Angeles. Now, the basis of our studio is all about storytelling, and to do so, we engage quite a number of different mediums, from film to music videos to broadcast TV commercials, all the way to large installations of projection shows on buildings, immersive interactive displays, also interactive mobile storytelling apps, and more recently, virtual reality, which is what we're going to be talking through here today. But before we get into it, let's take a quick look at some of the work that we do. So, thank you. So recently we were hired by Google to develop an interactive mobile application to take people on a virtual tour through the new Google Shop, which Bex had mentioned. Those of you coming from London might have experienced the first one that has opened up. The rest of us, we have another way to get there at the moment through one of these little devices. But this was a particularly exciting project for us because it actually involves a culmination of different technologies, some of which have been in development at Mirada for a couple of years now, and some of which are absolutely brand new. And on this project, we are putting together spherical, stereoscopic live-action content. We're developing our own CG elements to be able to be composited into that. We're building an interactive real-time mobile application, and we're also mastering in fully spatialized ambisonic sound. Now, has anyone here actually played with Google Cardboard yet? A couple of hands? Excellent. Well, to give you a bit of context, this is actually what's going on. Building on the concept of VR inside your pocket, the idea is this is a screenshot of the mobile application on your phone, which slips inside the old cardboard, and instantly you're transformed inside of this universe, which is pretty cool stuff. Now, taking a brief look at how we went into the content creation for this job, we knew going in that we were going to be dealing with a large amount of live action media. Like I said, filming stereoscopic spherical images on the Jaunt camera rig, which is a stitch of 14 GoPro feeds. We knew that they were going to have lots of different events coming in and out throughout the scenes, lots of variable retimes and fades and so forth to deal with, along with a bit of a unique brand of stereo imagery. So right from the beginning, it was very clear to us that Nuke Studio and Nuke were definitely the right tools and going to play a key role in our workflow for this. So now that after the live action has been created, the editing's done, we're now ready to online and conform our show. So jumping into NukeX, we start off here by importing our XML. We're going to tidy up the tracks just a little bit. And next thing, we're going to link up all of our raw media, most of which should be imported here. We'll see how Studio goes. It's found nearly all of it, not a bad conform. There are a few little stragglers that'll need to be overcut. So we're going to jump into the same timeline that's a little bit further progressed. And first off, you're probably wondering, what's wrong with this image here? Obviously, that doesn't look right. What we're actually looking at here is our raw media has our left and right eye stacked on top of each other in one 4K frame, whilst our offline was put together as a HD proxy of just one eye. Not a problem here in Studio, as we just changed our resolution of our timeline to match our raw media. And then we go down to find our offline, and we can see that that's living somewhere in the middle. So all we need to do is grab a soft effect so that we can move our offline into an appropriate location. In this instance, I believe it's up top, which is our left eye. So we can move that there, and then we can sift through all of our scenes, aligning all of our footage, constantly making sure that everything's in sync with audio as well. And like I mentioned, there was many different passes being stitched together in this show. So we've just got a little bit of lining up to do here before we're all ready. We're also utilizing Nuke Studio's clip tags to pass a lot of information from editorial that's going to be really helpful later on down the line. So once we're all lined up here in the conform, this is the point where we would normally render out all of our online plates and pass them into the compositing department. But here, we're very conscious about the amount of data that we're working with and all of the overhead on this show. So what we're going to do is actually package up this whole timeline, export it with a comp special as one complete shot, just selecting the online tracks, and we're going to have the compositing department work directly off the raw media. Now we can see Nuke Studio here is already ready to receive the render of that track back into the timeline. We bounce over into NukeX to inspect the export. We see that all of our raw clips are in place where they need to be. All of our retimes are taken care of. All of our fades are where they need to be. And we've also got a bunch of helpful information coming through from the clip tags so that the compositors know exactly which piece of which plate is intended for when they're making their assembly. Now on to the brave new world of spherical compositing. Let's take a look at the actual comp build now. As we're in NukeX, we can see that our comp has definitely grown a fair bit from the original Nuke Studio export. However, to get there from the beginning, we start off with our raw media stacked like you saw. We decouple our left and right eye with some pretty light little transform gizmos so we can take that forward and backward as necessary. And we're pumping that into the left and right eye views of Nuke. And then we're ready to basically make a first pass quick assembly of the comps, stacking all the passes together with a clean stitch, a very quick little rudimentary cleanup of the scene. And that actually gets rendered out and put aside, and we're going to utilize that in a little bit. Then we're ready to continue tidying up our scene. Now, anyone who's ever worked in stereo is definitely going to be constantly grateful of the power of Nuke's multi-view workflow. Now this becomes particularly important when working spherically, because when you're dealing with a 360-degree image, you very quickly realize just how much more work there is to take care of than a conventional frame that is only a small slice of the world. Now, part of this phase, we're actually also going to be scanning through our entire scene, looking at all of our stereo lineups and taking care of any discrepancies there, making sure everything's in line. Now, with this type of stereo, it's actually a little bit unique, where Traditional stereo, we have a left and a right eye camera that shares a pivot point so that the convergence is always married together. However, when you're experiencing virtual reality that is not a real-time render of a 3D scene, this is effectively what's going on. When your head moves around, you're scanning across two flat textures, and you can instantly see that it appears that the stereo convergence is broken and it shouldn't work. So in order to make this work, there's a few different styles of unwrapping this sphere at the moment, which is one of the big questions of how we process spherical VR at the moment. Now, this is something when filming with the Jaunt camera rig, they're very successful at unwrapping and stitching together all of these passes. And our challenge comes into how do we create our elements to marry into that. So what we developed is a 3D lens shader, which is kind of a slit scan view, which basically renders the entire scene from a different angle all the way around, resulting in one flat equirectangular image that allows us to utilize all of our standard 2D compositing techniques without breaking the stereo effect. As what we need to do is build a flat frame that has a stereo convergence that is maintained across the entire image simultaneously so that the stereo works at any angle the image could be viewed at some later date. Now, putting our scene together here, we're also really thankful of the export from Nuke Studio taking all of the heavy lifting of the timings and the edit points that are going on throughout our scene. Because a shot like this, we're actually putting together about 20 different passes of 4K frames over about, each scene's about a couple of minutes long, equating to about 4,000 frames roughly. So it's a lot of media to manage, so Nuke Studio really does the heavy lifting there. Now, another thing to take care of when you're working in spherical compositing is maintaining the left and the right side of the image so that they match each other. I can assure you it's not terribly fun, you know, building a really beautiful comp, exporting it, having it progress and compiled in an application to review it, only to realize that there's a big seam down the middle behind you at the edge of the frame. So we have some really light transform gizmos here to basically wrap our scene around on itself so that we're constantly taking care of that stitch. We can see here the way that the stereo is actually working in a flat basis. We can inspect all of the stereo depths, both spherically and flat, and we can confirm that they're functional. As a little bit of a cheap look around, we can jump into the OpenGL and tumble around the world to get a bit of a sense of what the experience is going to feel like once it's compiled down in the application. And we also bake out a few pre-renders of some example scenes at a bit of a higher quality, just constantly confirming our composite. We're really happy with some of the tools that the Foundry is developing at the moment that allow us to inspect all of these aspects at higher and higher quality and better speed as this technology progresses. Now our composite is nearly finished. The final step is to decouple our left and right eyes again, stacking them on top of each other, and we can now render this out and deliver it to the Unity engine inside of the mobile app. Now, let's take a quick moment to talk about the apply grade gizmo that I kind of skimmed over at the end of the main comp there. You see, in a project like this, it becomes a little bit impractical as we have content and the application constantly iterating together and feeding back to each other. It becomes a little impractical to the schedule to have a live grade session at the end of the line like you would in a typical film workflow. And on the other hand, if we went with a normal broadcast workflow where we're grading all of our pieces together before compositing, in this instance, we would have been looking at processing about 75 different plates, equating to hundreds of thousands of frames that we knew were going to be comped down into just 7 different scenes. So it would have created a lot of wastage, a lot of overhead, and also another hit on the schedule at the beginning. So what we need is a solution that is non-disruptive to the process that can happen somewhere in the middle. Now, there's a few different ways to go about this, but our solution is staring at us in NukeX. So in the comfort of a Nuke Bay, with Nuke connected to all of our color correct broadcast monitors, we can schedule a live grading session at our client's convenience. And as we mentioned earlier, we had the compositing team immediately after the conform put together a kind of a rudimentary stitch and a flat basis for us to start grading from. And the rest of the composite is built on effectively flat material, and that is happening in parallel now. So once we're in our live grade session in the middle of the project, we can customize Nuke's views to show us all the different layups of our tiles. We can easily export still frames for our client and stack all of our views together and take care of our primary color corrections at first, making sure everything's in balance before moving on to our secondary corrections, which typically are going to require tools like advanced keyers, intricate rotomats, simple power windows, trackers, different types of image filtering like sharpening, blurs, denoises, shared grains across shots. All of these of which are available to us in Nuke. So we can utilize all of those. Again, we're also dropping some redundancy of task by doing all of this in stereo, so our left and right eyes are being managed at the same time. And once we're happy with our grade, everything's in line, our clients are happy, and we're especially happy. This is where the real value component comes in here, because again, as we're very conscious about the amount of data that we're generating on this show, instead of re-rendering a whole new version of colored online material to be reintegrated, what we can do here is take all of our grades, package that up into a gizmo that we turn into a facility asset that we can publish that is versionable, and it gets dropped directly into the main comp. Now this allows us to export our very next iterations of the comp that are completely up to date with the grade session that may have happened that same day. So when the clients get home, their next iteration is all completely up to date. And then we're ready to go. So this has been an incredibly effective way of managing our grades, and it also allows us an opportunity to make some slight tweaks or adjustments to the grade without having to re-go through the process or re-rendering or re-ingesting at any point. So as you can see on this project, integrating Nuke Studio into our facility has really opened up the communication flow from editorial. It's really saved us a lot of overhead, and it's been really easy to manage our large scenes that we composite together in Nuke. We also utilize our Nuke render farm that it's completely available to Nuke Studio, so we've got a lot of rendering power already in place. So this was a fantastic workflow for us on this show, and Nuke was definitely an integral part to the success of this. So from that, I just wanted to see if anyone has any questions.
I always have questions. We have one out here.
Of course.
There you go.
Did you say that the cameras on that joint rig
Yes.
were all GoPros?
Yes, the joint rig is a rig of 14 GoPros that are arranged in a sphere, and all of the feeds from that get stitched together in a fashion that is a little bit of their secret sauce to create that equirectangular flat image that effectively has every slice of the image rendered from a different perspective around the scene. Yes, I believe so. That was a very similar setup. Yeah, there are everyone's. This is a very new technology, and everyone's kind of or the new players are kind of building their own rigs and testing things out. And we've seen a few different versions of GoPro setups like that. We've seen a couple of versions of people doing bigger rigs with SLRs, and we're experimenting and building a lot of different rigs for this just to get into this new realm.
If we shoot, let's say we just even use the simple Kodak Pix camera that gives the domes, can we take that footage and go right to this application, or do we need to do one other application in between?
Well, currently it's been a lot of custom programming to be able to create that. The Foundry is working very hard on some tools to make this more readily available and wide, and I think John's going to talk about some of the things that are in development on that right now. So the answer is soon, I guess. Yeah.
So was Mirada on set as well? You guys were in
Yes.
for the actual shoot. So can you, just seeing a couple of the images there with the sound guy,
the raw media.
You kind of just glossed right over. When you're doing a shoot for VR,
Yes.
what do you have to think about that's different from a traditional shoot?
Fantastic question. I mean, there are a lot of things to think about that this realm, it throws up a lot of questions. You know, how do you shoot an entire environment? How do you have production material, people, lights? How does all of that exist in the scene without existing in the scene? So currently, we shoot a lot of elements in passes and pieces, and effectively it's painted and stitched together. So we do a lot of painting and standard removals, essentially.
So I would assume that I mean, obviously Nuke has been used widely, extensively in conversion of traditional film to stereo,
right,
or taking stereo footage and doing comp. I would imagine that those same workflows that we've been refining for years are somewhat invaluable.
Correct, and that's part of why we take the effort to unwrap the sphere in a special way so that we can work with all of our traditional 2D techniques and traditional stereo workflows.
So I'm going to, you mentioned taking the spherical cameras and unwrapping it, and you just sort of said, so we just made this quick slit scan.
Yeah, exactly.
Describe just a layman's term of what a slit scan conversion is.
And again, this is a realm where many people are kind of developing their own secret sauce. But effectively, what is happening is we're rendering every angle of the image is rendered from a different perspective as you go around a sphere. So effectively, the flat image is a stitch of 360 different vertical arrays of pixels.
And then the other thing that you very briefly mentioned that I wanted to dig in a little bit about was you mentioned piping this then into a Unity application.
Correct.
So is that an application you create, or is there a player inside of Unity to allow you to do the stereo?
It is. I mean, Unity has a lot of great open SDK kits, and so we program the interactive mobile app with the Unity engine, which is where we utilize their 3D engine to project 2D flat textures on spheres, and then connected with the accelerometer in the phone gives us the angle of the viewing experience.
And then just before you came on, I got a chance to go over and be photographed wearing some cardboard on my face. But there's also some augmentation. Did you do the graphics and things inside of?
We did, and that's another part of the real-time interactivity in the app that we built in is in the physical space. We have a lot of menu selections. As you look down, we have our interface menu available there, so it's non-disruptive to the rest of the scene. And throughout the different world, there's a handy little switch on the side of the Google Cardboard that works magnetically with the phone. So it's actually just a little magnetic slider ring, which acts as a button. So when we're lined up to a piece of interface material or a menu system that we've created that is connected, waiting to listen for this button being pressed, that magnetic field gets detected by the phone, and that's how we can create interactive menus.
That's pretty cool.
Yeah.
So I'm going to go back to the rotoing real quick, and then we'll go to the internet. So you showed, I was watching you, or some Nuke operator, brushing out the seams. Was that you? How automatic is it to take that and then apply it from left to right? Or is it?
It is very automatic, and that's another thing that we spend the time to make sure that we're working in this flat way so that we can pipe our left and right eye in together. Again, utilizing all of our traditional stereo painting and all the other transform tools that take advantage of that.
So even if 3D in the theater doesn't go over all that man hours, all that crazy amount of research and development that we did to enable stereo workflows.
Oh, it's still very appreciated.
Still very, very valuable. So
absolutely.
Let's hear from the internets.
Okay. First question. When the job landed, how long did you have to work out your workflow?
Great question. We essentially had a couple of weeks from when we were first talking with Google and John about the concept of this, and as it was very brand new, we had a few weeks of discussions of figuring out what we could do, what was the best way to go about it. So there was just a couple of weeks of lead time. But like I say, some of the things that we were building here. Things that we've been developing for a couple of years, especially as far as the interactivity and the mobile app build. And then, the very new aspects dealing with the spherical compositing. So that was something that we worked closely with John, talking about how they've figured out how to unwrap these things so that we can work in a 2D realm. And then, we had some of our internal developers working for, like a few weeks to get everything neat and tidy.
Was there a moment where you were like,
Well, always at the very beginning when you start to ask these questions that, spherical compositing and VR throw at you, there's a lot of times of like, wow, how do we really solve that? But that's the exciting new realm that we're in.
Right.
Yeah.
Right. No, that's cool. What was the resolution of your final Nuke export, and what engine did you finish in? I think we've answered some of
The final engine was Unity inside the phone, and the resolution at the very end of the line was 2 HD images stacked on top of each other. So in the Unity engine, it's a 1920 by 1080 sphere, each for the left and right.
Okay. How do you QC the sphere wraps in Nuke to make sure there are no seams?
So a couple of different ways. We wanted to, whilst we're in compositing, we kind of want a really light and flexible, easy way to make sure of that. In this instance, we effectively, because we're working on a 2D flat image, we're able to use fairly simple transforms to effectively take the plane and put it on the other side of itself and then move it over, creating the same effect of a spherical wrap. And then we were also using some Oculus material coming directly out of Unity to do some live views so that we didn't have to compile the application for the cardboard. And we're also very excited about some of the new things that the Foundry are working on to enable this to be even faster directly out of Nuke.
And that's up next.
It is.
Oh, got 10 minutes to wait, people. Okay, that's all from me.
No worries.
I want to add one thing. But you had it, I think it was your first slide where you said, Nuke Studio, the right tool for the job.
Absolutely.
And that's been a running theme today.
Yes.
And I personally believe, and I want you can tell me I'm wrong if I say something. I don't think there's any other company on the planet that's as well positioned for VR production than the Foundry.
Absolutely. I mean, it was a no-brainer for us. The flexibility of Studio and its integration with Nuke was really fantastic. And its workflow is improving all the time, and we love it for sure.
Thank you so much, Andrew.
Thank
No
you,
worries.
Andrew.
Thanks,
Round of
guys.
applause
Enjoyed
for
the
Andrew. So we're going to take a quick 10-minute break, and then we're going to be back up with the future. John Wood-Elton's going to be here to show you some cool tech previews, mischiefs and stuff that we've been up to back at the HQ. So John's up in 10 minutes' time. Questions for him, #TFNAB. See you soon.